Welcome to this session. This class we are going to discuss about the concept of directional derivative of function, which has continuous and continuous first order partial derivatives. So the theorem states that if we have a function of two variables x and y, which has continuous first order partial derivatives, then the directional derivative at any point xy in the direction of the vector u given by ai plus bj is given by the directional derivative in the direction of u vector of the function f is partial derivative of f with respect to x times the component of I, then plus partial derivative of the function with respect to y times the j component. So this is the main result. And how to find the directional derivative. So let's do a problem on how to determine directional derivative of a function with respect to a given vector. So problem. Find the directional derivative of the function f of x comma y given by x cubed minus 3xy plus 4y squared in the direction of the line that makes an angle of pi over 6 with the x-axis. So that's a good problem. So the first thing we have to sketch this vector, which makes, or this line which makes an angle of pi over 6 with the x-axis to determine the vector u. So solution for this, I remember pi over 6 is the same as 180 degrees over 6, which is 30 degrees. This x is 0. This is the y-axis. Now I have this to be theta, which is pi over 6. So let's see the component in the I direction and the component in the J direction. You see, this is a right angle triangle. So from, if you call this one X, call this one Y, so the vector U has X component and Y component. So using Gauss-Chota, then with respect to this adjacent, so then this is the, let's call this one vector R. Remember, this u is a unit vector, so which means the magnitude of u is 1. So this r is just 1. So from Oshachota, we can define cosine and sine. So sine of theta is opposite of hypotenuse. Opposite is y. Hypotenuse is 1. So which means y is just sine of theta. Y equals to sine of pi over 6. So sine of pi over 6 of sine of 30 degrees is a half. So y is a half. And cosine of theta from this one adjacent of hypotenuse, adjacent is x, hypotenuse is 1, is given by x equals to cosine of pi over 6. So cos of 30 degrees is √3 over 2. So therefore the unit vector u is x, which is cosine of pi over 6i, plus y, which is sine pi of 6j. And the values of this have 3 over 2 I plus a half j. Remember, this is how we represent a unit vector. So the u given in the theorem means unit vector. That's why we have this cap notation. So direction derivative of the function f of x in the direction of u is given by f at xy times a, and a in this case is √3 over 2 plus f y of xy times a half. Now, the function given f of xy is given by x cubed minus 3xy plus 4y squared. So this means fx or partial f partial x will be 3x squared minus 3y, and fy partial f partial y will be minus 3x plus 8y. So we'll have directional derivative in the direction of the vector u of this function will be, this will be replaced by 3x squared minus 3y. So we multiply this by √3 over 2 plus this will be replaced by 8y minus 3x. We multiply by a half. So which we can rearrange as half is common, so we factor out a half into √3, 3x squared minus 3y plus 8y minus 3x. Or we can just put brackets here. So this is a solution. Actually, we can, in fact, factor out 3. So we have 3, then with 3. Can further simplify this to direction derivative of the function in the direction of u is a half into 3√3 x squared minus y plus 8y minus 3x. So this is what we have. So when you are asked to find the directional derivative of a function in the direction of a unit vector, you simply get the partial derivatives, first partial derivatives, and then put them into the formula as specified in this theorem, and then multiply by the components of that vector in order to find the directional derivative. Thank you.